so Martin's sick. So Martin's not here because he's been retching his guts out all day. And so I threw together a couple little things just to show some stuff about updates on libp2p, right? Thank you, 2 people, for showing up. Patrick, I know you have to be here, so it's okay. So libp2p has been doing a lot of work on interoperability testing and performance testing for the last, I don't know, year or so. And these are just a couple of screenshots from this page down here. This link goes to a GitHub page that shows all of our interoperability testing output, right? So we have web transport, interoperability, quick v1, which is the one I was just showing you. Basically, you can see we've set up this infrastructure where you have a dialer and a listener. You have listener versions across the top, dialers down the bottom. Green box means that that version can dial that version, right? And the cool thing here is that it's fairly easy to add new implementations, and this is actually going to help drive a lot of consensus going forward as we nucleate, because there's roughly 12 different implementations of libp2p at this point, and part of our key governance function will be like, hey, what does it mean to be a libp2p implementation? And part of that will be getting into the interop testing framework so that we can see what your level of compliance is. The really important one here, I think, is this quick v1, because you can see that this covers basically all of PL's properties, right? All of PL's software that we care about is either written with Go or Rust or JS. But we do not have quick support in JavaScript simply because we're waiting on Node.js, and of course the browser vendors are never going to give us raw web transport. So we all know where they sleep at night. The latest here, you know, like look at these TCP noise, Yamix stuff. We're getting some pretty awesome, I mean, basically everything dials everything at this point. You can see these are all green. WebSockets in here at the bottom, that kind of stuff. Okay, so the other thing that's interesting, I'm not even going to use my slides, I'm just going to show you guys. Let's see if I can get this to load up. The other interesting thing is we've been doing, I mean, we do a lot of other interesting things, but just from a high level thing that would be related to Filecoin, is we introduced a new perf protocol for clients to report observed bandwidth from other peers, so peers can report on other peers. And we dump it into this bucket that allows us to do some numbers on it. I think you guys may have seen this already. I don't know why this isn't loading here, but we have a server over in US West 1 on AWS. I don't know why I can't move this, but then there's another one over here on the East Coast too. This walks you through how to run it. This is 1 by round trip latencies. You can see that with the quick implementations, so here's TCP quick, you get a slight overhead because it's doing a handshake and it's doing stream muxing. But you can see that even between these two machines, our latencies these are in milliseconds, well, that's in seconds. So it's 123 milliseconds, you know, Q1, sort of the median's 125. That's important to keep in mind because the next graph looks bad, but it isn't. Let's talk about this one. So this graph is the throughput, and I think the title is wrong here. It's not 100 megabytes. Okay, so what we did here is we changed our testing setup so that it matches iPerf, which is the thing on the far end. So we have a 5 gigabit link between two machines, east and west. And if you run the iPerf test, which is it just blasts data between the machines as fast as possible for a whole minute. It's sampling every second. You can see that iPerf gets up here really close to the theoretical maximum, 4.78 gigabits per second, okay? These all look really bad, okay? And some of them are, but the ones that are not bad, and I can explain them here, and let me scroll down here so you guys can see these here. The ones that are not bad are these here, these quick ones. These are really interesting because the reason these numbers are so much smaller than iPerf is because what iPerf does is it ramps up the send windows until it saturates the entire available memory. So it is writing out to hardware like gigabytes at a time. And Go libp2p, Rust libp2p, they have a resource manager that caps the send buffers simply because it's a multi-stream library and we don't want any one stream to be able to exhaust all of the available memory. And we have reasonable caps on this stuff. So what you're seeing here is actually a latency bound number because it has to do round trips for the back propagation or the back pressure on the amount of data it can send. And so we're doing the same kind of test as iPerf. We're ramping up our buffers until we get to our resource manager max. But because we have this 120 millisecond round trip before it can send more data, we're seeing these numbers much lower, basically, because it sits there waiting for the round trip to come back before it goes and sends the next one. There's two ways.
Have you considered doing this with a lot of streams to see if you because this is presumably with one stream.
Right, and we could do an aggregate, right? Like where you have like 10 streams and yeah, we've considered that. We know what it would do. It would look just like iPerf, right? And we could actually see what the overhead of libp2p actually is because it would saturate the available memory, right? And but we wanted to make this just as a single stream kind of number. So anyway, we could make these numbers look just like iPerfs on a single stream. The trick is you have to get two machines closer together so they have more round trips, and then we'd have to go and hack the defaults in libp2p so that the available memory is much bigger for the send buffers. But this is actually quite impressive. I think the one thing that's really important to look at is when you get down here to, this is Rust libp2p TCP. It's capping out at 18 megabits per second, and this is because of Yamix. The Yamix implementation needs work. Let's put it that way. It's a dumb implementation. It caps out the send buffers to the available memory divided by 8,000 or whatever like that. So it's very latency bound, and we're not getting a lot of throughput. But when you go over to Quick, we're starting to see a lot better performance, and this is actually due to some optimizations in the Quick library that are waiting to happen. So we're expecting numbers to get similar on Rust here pretty soon. And like I said, you know, we're not going to get the benefit of Quick in JavaScript anytime soon because of the browser vendors. But anyway, this is kind of what we've been working on that is ho-hum, mundane, you know, keeping the water going through the pipes, the lights on, all that kind of stuff. This is critical for us going forward because when we nucleate and we're going to be including other libraries and things like that, we're going to want to be able to pull numbers on all of those as well so that we're being responsible stewards of all the implementations, I guess. So having this infrastructure in place, making it easy to plug other implementations in is going to be really key to unifying the community around what it means to be libp2p. That's all you know, Martin had some more slides and he was going to show some more stuff, but he's ill, and so I just threw these together. I just wanted to show you that. The rest of this time was to just discuss libp2p and Filecoin or whatever you want. I'm happy to talk about the long-term vision for libp2p, but I don't need to do a presentation on it. So if you guys are curious, we can talk about it. But
what's the long-term vision of libp2p?
Fine. So there's two ways of looking at the future of libp2p. One is what I call the profit chasing model, where we apply a price tag to the cost of using libp2p and maintaining it. And it's used by a lot of really big projects. We have Celestia, we have Ethereum's Beacon Chain, and obviously all the protocol labs platforms and stuff. We know what it would take. It takes a couple of engineers full time, and we know what that costs. And we can put a number to that, and we can park what I call a spec space. I don't know why it's a bad name, but it just comes into my head. It's a small governing body that owns the specs, owns the website, all that stuff. We can put that somewhere that provides good stewardship. There's no staff there necessarily. And we can have a funding vehicle that writes grants or contracts for the couple of heads of engineers to keep this thing going. And we go out to all of the organizations that rely on libp2p, and we say, this is what it costs. You either hire engineers in-house to maintain it, or you donate money into this broader project, and we'll do our best to maintain it. That's one vision. That's boring. I don't want to do that. I mean, we'll start there. But the future, I think, is actually more about what libp2p was originally started to do, which is, well, let me ask you guys a question. What do you think is the logical conclusion if you take peer-to-peer networking to its logical conclusion? What does that network look like? Like, what are the peers? What infrastructure do you have? Do you have any infrastructure?
Mobile mesh networks.
Exactly, right? Like, no infrastructure other than peers, right?
libp2p as it's written doesn't do any of, like, that's a whole other problem space that people are in, right? Like, it's not actually the problem space that the libp2p technology stack as it exists. And I don't mean to say that should take away from a vision, but like,
I know.
Like, but there's a thing, and like, I'm trying to figure out what the value of the thing that exists is. And one downside, just to be transparent, is that value has been going down over time, because the technologies libp2p originally was designed to replace have been getting better to the point where they're not as problematic as they used to be. Like, the things that I would see libp2p off, there's like a few different problems in networking that are annoying to solve, that everyone has to solve who wants to do something peer-to-peer, that don't exist in the current stack. One is like a pretty easy way to connect browser nodes. That's an annoying thing right now. It's also
going browser to browser.
Browser to browser, right?
Yeah.
And there's WebRTC, but doing all the setup is just a lot of work. Hole punching, bunch of work, right? Just like annoying to do, right? And then
we have hole punching.
No. I'm telling you what I think are the values of libp2p as it exists, right?
Yes, Ham.
Then and then the cert stuff, right? SSL, super annoying. Like, it's a really annoying aspect of the internet, being able to just exchange certs, that are in a peer-to-peer manner is really useful. Those three things are the things that I think are distinguishing values of libp2p today.
I would totally agree with that.
Yeah. Now, and that's so just as an interesting counterpoint, I think the IRO of what they're doing is an interesting question mark. Like, they are not using libp2p, right?
Yeah.
They are building using existing technologies, using the baseline technologies, and then trying to fill in those holes. And I think that I disagree with them. I think that's going to turn out to be a bunch of work that they don't have time to do in their small company, right? Like,
yeah, they're going to basically rewrite libp2p just in their own flavor.
But I think their argument would be that there's a bunch of things in libp2p that are left over from stuff that was trying to be solved once upon a time that are not useful. Like I definitely, one thing I've heard a lot is like going all the way up to an abstract stream with this whole multi-stream, and then the whole negotiation protocol. Like, it's all too heavyweight to be performant. So like, I understand why people do that. Like, I wonder, I guess I'm just trying to figure out like what, like, and then like, how do you get from there to like mesh networking, which is a problem space many people are already in and are like much farther along on, and has nothing to do with the current technology. I don't know. I'm just throwing these things out. Question marks. Question marks for your future nucleation plan. Yeah.
Well,
Can we go back to your, what libp2p vision future is? Because you said less infrastructure. What is the vision of what libp2p ends up being?
well, there's, just to comment on what Hannah was saying, there's, I think, 9 fundamental problems. And I know you guys have heard me say this a million times. I'm going to make a t-shirt that just says 9. Which is double entendre because it's German for no, Dave. Please don't tell me again. I think there's these fundamental problems that exist in every decentralized network, and they're hard. And we only have reasonable solutions for about half of them. And it's a very interesting model when you evaluate systems that claim to be decentralized. And for 2 reasons. One, any decentralized system that doesn't provide a decentralized solution for any of these problems opens itself up to a centralized corporate capture. So the fact that Git itself does not provide for peer discovery, it doesn't provide for global state, meaning like here's where the canonical repo is. It does in the sense that there is a global state in the repo itself, but not the metadata around it. And so coherence and introduction, like there's no good introduction, which is the cryptographic material used to grant access and enforce policies on commits and all that stuff. Anyway, it leaves a few things out. They did not solve some of these problems, and it made GitHub inevitable, essentially. Same thing with Bitcoin and Coinbase. Same thing with secure scuttlebutt and the super nodes. It's a model that you can evaluate existing decentralized systems to see where the gaps are, what needs to be solved. One of the things that Bitcoin notorious, and most, actually all decentralized systems still don't really have a good solution for is they typically cannot do all of the necessary communication for the network to function or the service itself to function in band. Like in Bitcoin, right? I want to send you, or any cryptocurrency, I want to send you some, Hannah, I have to ask you what your address is, and we have an external system for that, right? There's no way to do it internal to the blockchain platforms or to the Bitcoin network or whatever. Anyway, my long-term vision here is to, and this is going after, like I said, one way is to put a price tag on and do the profit chasing model. The other future for libp2p is the dream chasing model, which is we try to solve these problems. We organize a community around solving these problems. Because what you get when you solve all those problems is you get a thing I call a metastable network. It's a network that self-organizes and self-sustains itself with zero fixed infrastructure. And is therefore outside of the realm of normal control over internet systems. It doesn't rely on DNS. It has no servers to be shut down. It's an extremely powerful idea. These networks would exist outside of any organized control in the world. And it's within our grasp. There have been a couple of tools lately, and I've been talking to a lot of the authors of creating these tools that are getting really close. And they are not mesh networks, but they function like that. They're overlay networks. For instance, like Quiet is a brand new tool that is like, it's a replacement for Slack. And it uses the Tor network to solve a couple of the problems that like libp2p doesn't. It is built using libp2p over the Tor network. The cool thing about Quiet is it has reasonable solutions for all 9 problems. And it's really good at it. You can create custom groups, closed groups of friends, and the state persists and the network persists even though they join and leave randomly. I'm not exactly sure if the coherence is stable if everybody is all the time, but we do know that statistically, if you have north of somewhere between 60 and 200 peers, there's a floor. If you have enough peers, right, there's a guarantee that this network will exist. There will always be at least 2 peers online, given average use times of computers. I'm rambling here a bit, but what I'm trying to get at is that libp2p is the best implementation we have that automates a lot of the really hard things in peer-to-peer networking. And it gets us a long ways down that road. And libp2p needs to be part of something bigger if it wants to be more than just the profit-chasing model where we assign a price tag and we get the donations and we write some grants or contracts. And so my long-term vision for libp2p is to use it as the launch pad to raise more money about this other idea, this other dream of building things that actually exist outside of the current censorship regimes and control systems. So I don't know, any questions about that? That's kind of what I'm hoping to get at. There's a lot of people, as Hannah said, have been working on this for a very long time, myself included. The problem I see in that community is that there's a lot of short-term projects that come and go. We've had a whole bunch of these things come and go, and there was never any continuity of thought because there was never a space, a mental space in which all the researchers were pooling their information. There was no label we attached to it. There was no mailing list. There was no event where people would come and present. There's no award for really good work, or there's no money for directing at research. And so the opportunity I see here during nucleation is to use our current market position and the current excitement and the possibility of tackling these problems to create that space, create that mind space, to get everybody in the same room and to start using the same terms and the same labels and the same names for what we're trying to do. And yes, it does include mesh networks, but it's not hardware specific. And it's not implementation specific. It's not even libp2p specific. It would be, dev-p2p could be in there too, but it's not even just the network stacks, it's also the applications. So, I don't know, my long-term vision is to build that, because I think that can be funded to a larger degree and can have a much bigger impact, since everybody talks about impact around here, can have a much bigger impact in the future, while also meeting the needs of all the users of libp2p and keeping it relevant. On the front of what you said, Hannah, libp2p, yeah, it has a lot of cruft in it. But there's no reason for us to strip it out, because it might be useful for someone. Like we just ran into this the other day about Mplex being not a default multiplexer. And the Ethereum people were like, wait, what? We actually use this, right? And what we meant by that was in the Go and Rust and JS implementations, this is not weird. We do not make decisions for the whole libp2p project, but we do employ the maintainers of those implementations. We decided that we were going to turn it off, or we were going to try to move in a direction where it's not a default thing. We're never going to remove it, because if someone needs it, they can maintain it. It's fine. It's an open source project, right? But the defaults do shift. And I think what we know now from those performance tests and the interop stuff and all of the work we've done over the last year optimizing libp2p is basically what Martin and Marco said in Brussels. The libp2p stack, a minimal one, is quick with multi-stream select. That's it. Now you have a whole bunch of other protocols that can layer on top of it, Gossip Sub, Kademlia, all those other things. And we now see that as sort of an ecosystem of capabilities. And that is what I mean by going in the direction of, hey, there's these 9 problems. Here are the best ways to solve them. That's encoded in this protocol and this protocol and this protocol, and those all sit on top of the minimal libp2p stack. And what's really interesting, the other day I was just playing, now that we have HTTP both at the transport level and at the application level, protocol level, is that if I were to do a very simple trustless gateway protocol implementation, we can build something that's effectively a minimal IPFS stack. Because I have transport, I have multi-stream, I can do Kademlia, I can do gossip sub, and I can send and receive blocks via an HTTP request. That, just looking at the numbers of the IPFS network, that is a minimal IPFS stack. It's basically compatible with most peers in the network. And we, you know, the narrow waist here is the protocol string negotiation, right? Everybody knows to talk that. So, I don't know. I'm rambling again here about libp2p, but there's no reason that the crufty parts of libp2p should make it less relevant. That doesn't make it less relevant. What would make it less relevant is if we weren't keeping up. And thankfully, we're actually leading on the front, on the quick front, and on being willing to integrate HTTP, both at the transport layer and at the application layer. We're very responsive to the market. And I don't see that stopping anytime soon. So, I don't know.
I actually think that's probably true, and also there's probably, you're still struggling with some leftover perception that maybe that in the past they weren't.
That's what this perf work is all about, right? That graph is actually bad. We're actually, I want to do a test where we have lower latencies and maybe do a multi-stream test like Will suggested, so that we're posting numbers that are closer to the theoretical maximum. Because I know the overhead of libp2p is basically zero, because there's nothing on top of that quick stack. Right. And naked quick is almost as fast. It's like within a fraction of a percentage as fast as just raw TCP.
Yeah.
So
now it is. Yeah.
Yeah. Now it is. Thanks to us, actually. Thanks to Martin's optimizations, and thanks to our, you know, we've been pushing.
Martin wrote the quick in Go. Yeah.
Yeah. Exactly. That's another example of us leading. So,
What does libp2p need from Filecoin?
money. Engineers.
I saw Ayush look up at that.
Feedback more than anything. You know, as we nucleate here in the next couple of months, what seems like something coherent, like people you can call, and it's a team that meets, and we show up to the all hands and we give reports, that's going to be less and less coherent. It's going to be much more ephemeral. People are going to spin off and, you know, go work at other companies and, you know, go do contracting and all that kind of stuff. I think it's going to take a little bit more effort from the users of libp2p to stay connected and to get their needs heard. I'm going to do everything I can to create an open space that involves everybody who's using it in the governance and running of it day to day as much as they're comfortable. But yeah, I think it's just what we need is people who are willing to keep an eye on it and give us feedback. I will come knock on doors, but again, like, we don't know if there's going to be just a tiny bit of money or if there's going to be a whole bunch of money. I'm hoping for the latter, but planning for the former.
I'm just curious. Do you guys talk to the IRO folks at all? It would be.
We do.
Okay, you do. Because I would just imagine right about now is when they're realizing what they bit off, and you know, now might be a good time to be like, you didn't have to do this.
Well, I mean, it's always a big tent. We didn't kick them out. They went off and did their own thing.
Yeah.
I wouldn't say we talk to them every day, but there is definitely back and forth.
Yeah, like either they've come up with great innovations that could be incorporated, or they're wishing they hadn't taken that on. One of the two, and it's probably a good conversation to have either way.
Yeah, exactly. Probably more productive over beer than over Zoom, but
How do you think of engagement with Filecoin? Like, Filecoin is not a single person. It's not just Ayush is Filecoin or so.
Well, I
right?
thought it was. I thought he was.
There's a set of like core Filecoin nodes talk to each other. There's some gossip sub. There's some various messages that go on there, and there's a set of people who manage that chain protocol, which has not evolved so much in recent time. Like, we're still using the same gossip sub to send messages. Like, the contents of them have changed a little bit. We haven't, done too much besides update the libp2p dependencies. But as IPC comes in, which is a different set of people, they're starting to look at different connectivity topologies, and suddenly there's different asks and different interaction at a libp2p level that's not the same libp2p subset. And then likewise, the actual market's data transfer is a whole separate set of people, because it's different people who aren't in those same conversations who are managing the Boost or Venus markets implementations for how the bulk data is actually getting transferred to a different piece of software. So there's at least 3 separate communities around what it means for libp2p integration and use in Lotus or in Filecoin as an ecosystem to be. And I wonder if we are losing something by just talking about Filecoin and should be talking about sort of specific interaction points.
Actually, that's probably really productive. I guess I would answer that with a question. I mean, how well do you feel we are visible? Are we visible? Do you feel like you know who's on the team and that you can get your concerns heard if there are bugs? I mean, I know we were supposed to have a panel of experts who know things about libp2p, but I'm happy to just stand here and answer questions all day.
I mean, yes.
Does it feel like we are being available enough?
I think so. The answer I was going to give is I update dependencies, and Quick says it won't compile against my version of Go, and that's how I know that libp2p is there.
We are fixed. Actually, I think that's fixed.
Yeah.
It's fixed.
Like forever?
Yeah, like forever.
Oh, good.
I think that happened like last week or 2 weeks ago.
Marco,
No more code interface breaking changes. That would be the other way I learn. Oh,
Yeah.
wow, this used to be a public struct, now it's private. Yeah.
The thing that we could use help with now is pressuring Google's core, the core devs for Go, because apparently they've decided they want to re-implement Quick themselves for the standard library rather than to use the perfectly good and highly optimized one that we wrote, or that Martin wrote, I should say.
But that's like perfect, because it's just like OpenSSL. Like everyone involved at HTTP3 is doing that.
Yeah. So if you know anybody who's on the core Go team and you have any influence at all or know how to bribe them or where they live so you can scare them, I don't know, like be nice, but they should not be rewriting it. It seems like very much like a not invented here problem. Like ego more than anything.
We have Filippo on some sort of retainer thing.
Yeah.
That might be.
They are aware of that. Like that's how the version thing got fixed.
But Filippo knows the core Go team. And
Yeah.
so one of the things we might channel through him is, why are you starting to rewrite Quick?
Believe me, Martin is already doing that.
Oh yeah. Yeah, you guys, Martin's all over it. That's why I even know about it. It's one-on-ones with him and he's rolling his eyes about the core Go team. All right, so if you guys feel like that we're available, what about in 2 quarters when we're not?
Yeah, well, like one thing that would be an interesting question. So there have been a number of releases that have been shipped where there's just like, I mean, they're usually good interface changes, right? But they produce harder upgrades, right, in, say, Lotus, and it delays them. And then often, the way it sometimes gets done is Martin goes in and does it. Or somebody else who knows enough to take the time out of their day. And my worry would be that in a future world where you're trying to survive, you don't allocate for that, and then also, or that's a paid contract, I guess. And the resolution of which is not that that someone pays you, but that they simply stop updating. And then also, or yeah, so like that's a complicated thing to figure out. And again, like I generally agree with everything that's happened, right? Like every change, I've been like, that's the right move, except Resource Manager, that thing's been a mess. But like, but on the other hand, it creates pain. Yeah.
Understood. That's actually good feedback. I know that in an ideal world, breaking interface changes take several releases and you have two versions, in parallel, so that you don't have to go and change your code just because you wanted to update. And I know a lot of times we have security fixes that force updates, and that gets particularly painful because the security update then would force an interface change, and you
honestly just like more information about that. Like, I don't know, do you guys document that somewhere when someone's about to do that upgrade? It's in the release notes.
Yeah,
I guess so,
we could do it better though, and I think I'm actually in the process of writing what I'm calling the community improvement proposal.
Yeah.
Which improves the community. Well, the point here is that I want to suggest to the rest of the libp2p implementers, both inside and outside of Protocol Labs, agreeing that everything's just going to happen on GitHub. We're using discussions. Because we have a bunch of different implementations, we're going to put a common banner. I'm suggesting we put a common banner on all our readmes, so we're going to bring back WebRing technology so that you can just click through all of them. Each one will have its own discussion. The top level libp2p/libp2p will be governance discussions, event discussions, high level discussions about community issues, including, hey, Go libp2p is going to break the interface soon, and have the discussion over there in the Go libp2p, but those level announcements I think would be boiling up to there. I want to get away from Notion and do all of our documentation and write-ups and proposals in GitHub. I don't have a good solution. I'm thinking maybe HackMD linked to GitHub for commenting and group editing is probably the best solution at this point, but I get the value of Notion. I just don't like that it tends to be a black hole. I want everything to be on GitHub from now on as soon as possible, and I don't get to make that decision. I'm making the argument right now to try to build some consensus around that, and hopefully we'll get that executed soon.
Do you use GitHub projects, and is your project public?
I'm sorry, what?
Do you guys use GitHub projects, and is the project public?
So that's the other part. So some of them already do, but not all of them. So the JS libp2p implementation is really good about this. They have Kanban boards, they have the community calls as stand-up, and they just go through status and all the work. And that one's coordinating work across several organizations.
I don't know if that, which I see as much more of an internal roadmappy thing, is as like the problem that we started on here was what is the high signal to noise ratio communication channel that people can be following to just get notified of. In two versions, there's going to be a breaking thing of this interface and things of that nature. And I suspect that broadcast is about a curation thing rather than everything's public and transparent, which also great, good future, good development practice, keeps the different libp2p communities visible to each other.
I take full responsibility if you weren't aware of some of these things, because it is my job and to make sure that these things get communicated up and out. And we have been announcing things on discuss.libp2p.io, but I do know that there's very low interaction, very low engagement there. And we do surface things mostly in Slack, and you'll see it come up in Andres reports.
Just to be clear, I would say I don't make a proactive effort to follow. The interesting thing, just so you know how this would happen, right? I wouldn't start with, I'm going to update libp2p. What I would start with is I just shipped a feature in this library that's somewhere between libp2p and like Boost, which is on top of Lotus, which is on top of a bunch of IPFS-y things and Boxo, and there's you guys you have the crappy position of being at the very bottom, where everything you do affects everything, after that.
Or the Machiavellian position.
Yeah, totally. You want to cause destruction, you have much. So I'm oh, okay, so I want to update Boost. Oh, Boost needs a Lotus update. Well, that's usually the end of the conversation anyway, because that's a huge thing. But oh, Lotus can't update, I can't put this update in Lotus that's from Boxo because Boxo updated libp2p, which means that Lotus needs to update libp2p, which means that Boost needs to update libp2p. And so therefore, that entire chain now needs to be updated, and every step has a breaking change, and I'm in charge, and I am not the person who has anything to do with with any of these projects. That would be my scenario that I do a fair amount.
You're welcome. I'm sorry, Hannah, if that makes a lot of pain for you. I'm happy to better coordinate with you.
Yeah, no, it's just that I don't know that there's a good solution, but we've done that a bunch of times.
That is the nature of software engineering, typically. I think the only way you can do that is try to manage the chaos, but the chaos will never go away. And you know, the one person that does this the best that I could try to emulate is Steve. Big Lep, man. He's really good at making sure everybody knows this is coming. Here it comes. Are you ready? And
So I think, why don't we do a final thing and then,
Yeah.
because I think we've got 15 minutes till road mapping and we should
Yeah.
take a break.
yeah. Thank you guys for showing up. I mean, I know that this is a Filecoin thing, and libp2p is sort of the unsung,
Hero.
piece of this. Yeah, I guess the hero. We're the carburetor on the motor under the hood. I don't know. Something that nobody ever thinks about until it's broken. All right, Will, what's your last question? What do you want to do?
I don't know if I have a last question. I think I passed.
I have
Molly
a
just walked in.
question.
She looks like she has a question.
So much context.
No regrets. On not using libp2p yet.
So I have a very simple question, and it should be trivial to answer. What are the chances we get pure packet transport in libp2p?
What are the chances that we get pure packet transports in libp2p? I think you need to define what you mean by pure packet transport.
So essentially, I just want to. I don't need at most one. I need at most one with lowest latency possible.
Oh, you're talking about you don't need multi-stream.
Yeah,
You don't need multiple streams.
like I need best effort delivery. I don't need like TCP or Quick, and
You're
I
saying
just
you
want
just want UDP.
I just want UDP with some encryption and
Well, then you should just use Quick. I'm not joking. That is literally the best answer.
All right.
UDP, it has TLS in it. The multiplexer is one single round trip, and it can be done 0 RTT, I think. So, and it's like just a few bytes.
all right.
And what you're getting out of that is essentially UDP, TLS at as fast as it can possibly happen. The only thing that I would caution you on is that using libp2p does have some constraints in the resource manager. So it has defaults for how big the send buffers can actually get, and that's why you were seeing in the perf graph, the numbers were actually down in like the high hundreds of megabits and not over 1 gigabit, is because it's capping out those send buffers. The way you get to saturating the channel is that you keep making those buffers bigger and bigger and bigger until you're sending 4 gigabytes at a time, right? You're just sending an entire, area of pages and kernel memory all at once, right? And so, if you want just raw horsepower in terms of moving bits across a wire, you're going to need to go in and tweak the resource manager in libp2p.
Yeah, my question was mostly I just want lowest latency possible. I don't need the speed.
Lowest latency? Yeah, Quick.
All right.
Yeah. That's why why the current best practice, or what we recommend
That's
for libp2p.
zero RTT work in libp2p. All right.
In Go, I should say in Go libp2p.
And pre-flight data is exposed as well, or no?
Ooh, that's a good question. I can tell you who to talk to about that.
It's Martin, but
Yeah, I don't know the actual answer to that, but it wouldn't surprise me because Martin's not the kind of person to leave stuff out like that.
All right. Thanks
you.
again, Dave.
Thanks, Will.
Thank you very much.
Thanks, everybody.